All right, let's work on parabolas. Parabolas, again, are one of our four conic sections that come from a three-dimensional cone that is intersected by a plane. And just depending on which angle you have the plane going, you could intersect a cone and cut off a parabola. So what we're going to look at is the equations of the parabola. We have two different standard forms for a parabola, and it's basically the only difference. You don't really need to memorize these formulas so much as you just need to understand it all depends on if your x is squared or if your y is squared. Now, when we previously worked on parabolas, we only dealt with them in what we called vertex form. Vertex form was y equals, and so it looked kind of like this. Y equals, we had an A out here, which represents any kind of stretch or compression to the parabola x minus h squared plus k. That's not standard form, that's what we call vertex form. We use the bad teenager analogy: inside the house you do the opposite, and outside the house you don't, to find the vertex. Well, right now we need to focus on some other aspects of a parabola. So standard form has a slight twist to it. Number one, the k is moved back over here with the y. Okay, so we have k with the y and h with the x. So when we do that, we're not going to use the bad teenager analogy. We're just going to keep in mind that both of them are going to be considered in a house. And so we're always going to take the opposite. The vertex of this parabola would be positive h and positive k. Likewise, and this is where a lot of mistakes are made, it doesn't matter which order they're in. The vertex is still positive h and positive k. So it's not the first number you see, it's the one with the x. All right, the difference between those two is when x is squared versus y is squared. Now, if you remember, we always looked at parabolas that had an x squared. They always opened either up or down. One way you could look at it is the y is the one not squared, and y goes up and down. The x is squared, which means you're going to have an equal amount on the left side and an equal amount on the right side. So the x is what's the mirror. Because when you square 3 or you square negative 3, you get the same thing. So the x is what is the same. Whereas in this standard form, the y is squared. Well, if that were true and the x is the non-squared term, we could be looking at a parabola that goes to the right. Or we could be looking at a parabola that goes to the left. We'll get to that in just a little bit. Okay? So I will just kind of show those right there so you can have that to focus on. All right. The concepts we're dealing with a parabola are going to be A, put it in standard form, and we'll get to that in just a few moments. But then we're going to be looking for certain pieces or pertinent information pertaining to a parabola. The first is the vertex. That one shouldn't be too difficult. We've already kind of done that. The axis of symmetry, the focus, and the directrix. Now, if you'll notice in this formula, you see another variable. It's called P. P is the distance from the vertex to the focus or the directrix. In class, we talked about the official definition of a parabola. It is the set of all the points that are the same distance to the focus as they are to the directrix. So the easiest point to deal with would be the vertex. That is a point on my parabola, and the distance from the vertex to the focus is the exact same as the distance to the directrix. What is a directrix? It is a line, but we're going to get to that in just, well, I wonder if I can find a spot to show a quick example. I'll use red. Please understand my graphs are not always drawn to scale. A focus is a point that is somewhere inside the parabola, and a directrix is a line outside the parabola. Something like that. So any given point on this parabola let's say this one, not necessarily drawn to scale. The distance to the focus is going to be the same as the distance to the directrix. All right, so that's what that concept means. But right now we need to focus on our equation. So let me put it this way. I put it over here. All right, here's one of my parabola equations, and it's in standard form. I have x minus something squared equals my y is in a parenthesis, and there's a number on the outside. So it should be quick and simple to find the vertex. That, I hope, isn't too difficult. In the house, do the opposite. So I have a positive 5 and a positive 2. So for my vertex, I'm going to put the point 5, 2. All right, now, the parabola is the one shape that I highly recommend you sketch. If you want to take real graph paper and put it on graph paper to help you figure out some of this information, go ahead. It could be very beneficial. Bare minimum, it really helps if you can sketch a graph. Let's see, 5, 2 would be something like this. 5, 2 would be right here. Okay, I need to stop everything and figure out which way is this parabola opening. Is it going to open up? Is it going to open to the left? Is it going to open down? Is it going to open to the right? Because that's going to make a huge difference in how I answer the rest of the questions. All right, this looks a lot like what we used to do. I have a y to the first power, a y equals x squared. I said something earlier, and I'm going to kind of harp on it because that's, I guess, one of the easiest ways to remember. Which one is your non-squared term? The y. Okay, so since x is squared, we're going to have a mirror image on the left and the right. In other words, it's going to open up or down. It's going to open along with the non-squared term. Y goes up and down. Y is not squared, so this either opens up or opens down. How do you know the difference? Look at this number. If it's positive, it opens up. If it's negative, it opens down. And this is positive. So I'm going to have a parabola that is something like this. All right, the axis of symmetry. The axis of symmetry is always a line. The line that cuts through my graph into two symmetrical parts. There's only one way to do that on this graph, and that would be right here. Whoop, that wasn't very straight. Now, there's a particular point that every axis of symmetry happens to go through. It's my vertex. Okay, I'm going to put that point right there. That was 5, 2. Okay, my axis of symmetry is a vertical line. This is the type of problem where you have got to really practice and make sure you know what is the equation of a horizontal line, what is the equation of a vertical line. A vertical line is an x equals. It looks like the y-axis, so you want to say y, but it's the opposite. So it's a vertical line. It is x equals a number. A vertical line is an x equals equation. Well, I know it goes through the vertex, so what does x equal? 5. There you go. All right, the focus. Where's the focus? I told you it is inside the parabola. Having the sketch really helps because I know which direction I need to go. To go inside the parabola, I'm going to have to go up. Okay? How far? P is the distance from the vertex to the focus. This number 8 represents 4P. So I'll use this color. 8 is equal to 4P. Divide by 4, P, which is the distance away from the vertex, must be 2. So I'm going to move 2 from my vertex to get to the focus. Well, which direction do I move? I'm going up. So if I want to go up 2, 1, 2, actually that's right up here, not drawn to scale. That would be the point 5, 4. Think about it. Up is the y-coordinate, so you're going to add 2 to it. Add 2 to 2, and you get 4, 5, 4 is my focus. What is a directrix? Directrix is this line that does not go through the parabola, okay? So for it to not go through the parabola, it must be a horizontal line. And here's a hint. If your axis of symmetry is vertical, then your directrix is horizontal, and vice versa. They're never the same. So if 2 is the distance from the vertex to the focus, then 2 is also the distance from the vertex to the directrix. Meaning, if I am going to go, and I'll use green, if I'm going to go up 2, I should probably have done this in maroon. I'm going to go up 2 to get to my focus, and I must go down 2 to get to my directrix. If I go down 2, I'm actually right here on the x-axis. This is the point 50, by the way, but my directrix is not a point. It is a horizontal line. And what is the equation of a horizontal line? Well, it's the opposite of what you would think. It's like the x-axis, but it's a y equals equation. And what does y equal? 0. Now, a couple things to notice. The directrix and the axis of symmetry are opposite equations. As I mentioned before, one is horizontal, one is vertical. They're never the same. So that's a neat way to check. Either they're both going to be right or they're both going to be wrong, but they better be opposite. Okay? All right, let's try this again. All right. That happened to me once before, and my students got mad that I didn't leave it up there, so I will leave that up there, and I will continue. All right, here we go again. This time, it's not in standard form. So guess what we get to do? We have to complete the square and put it in the right form. What I've done over here is I put a reminder. X is the one that's squared. So this is what standard form looks like when x is squared. I want the x over here. I want the y and everything else over here. So I am going to have to do a little work first. I am going to rewrite my equation. I'm going to leave a space because I'm going to have to complete the square to make it look like this. And then I'm going to add these two numbers to the other side. Well, actually, I'm going to add 4y and subtract 4. All right, let's complete the square. I'll move it that way. Take half of b, 4, square it, and get 16. I'm going to add 16 to complete the square. Well, if I add it on the left side, I better add it on the right side. All right, so what do we have? We have, let's rewrite this as x minus 4 squared equals 4y plus 12. All right? The left side is in the form I want, but the right side is not. I need to have a number out front of my parenthesis. So what I'm going to do is I'm going to factor out this 4. Okay. I now have it in standard form, so let's go. My vertex is at 4, negative 3. 4, negative 3. Let's draw a quick graph. Let's see, 4, negative 3 would be over here. 4, 5. 1, 2, 3, 4, right there. Which way does it open? Look at your non-squared term. That would be the y, so it must open either up or down. This number is positive, so it must open up. So it's going to be something like this. All right. My axis of symmetry is, I'll use red, going to go right through there, and right through the vertex. So it is a vertical line, which is x equals, and what does x equal? 4, because it goes through the vertex, it must use that same x. Okay, the focus. I have to figure out what P is. I need to know how far am I going to go from my vertex to get these two? Well, 4 is going to be equal to 4p. Okay, 4p is this number right here, 4. So divide both sides by 4, and you get p is 1. That means I'm going to move 1 away from the vertex to get to my focus. Which direction do I move? Well, remember, the focus is inside the parabola, so I must have to move up 1. Oh, I want to use this color again. There it is. Now, I forgot to write this one. This is the point for -3. So when I moved up 1, I ended up at 4, -2. And so 4, -2 is my focus. My directrix is going to be my green marker. Trying to keep up with all the colors here. If I went up 1 for the focus, I must go down 1 for the directrix. And the directrix is a horizontal line. The horizontal line is y equals, so I'm going to write that down, y equals, what is y equal? It is not the same as the focus. I went from a y of -3, I went down 1, which means I am at -4. Let's try one more. Last one. Okay, this one's different because I have a y squared instead of an x squared. Okay, I want my y's together. So I'm going to have to rearrange this. Notice that, the proper order would be x comes before y, but the squared comes first, so they're a little mixed up. You got to just keep an eye on that. I have a y squared and I have a plus 6y. I'm going to leave a space. I'm going to move my 4x over. And then I have a minus 25. Didn't mean to do that. I didn't mean to have a 4 for both of them. I wanted to give you some variety. Oh well. I've got a good idea. Let's change it to plus. If we change it to plus, let's see what happens. This becomes a minus. Might as well throw that at you. So let's make it a minus 4x. All right, here we go. I need to complete the square. Half of 6 is 3 squared and get 9. So I have to add 9 over here. All right, so what do we have? We have a y plus 3 squared equals a negative 4x minus 16. Again, I cannot work on my vertex until I have it in the proper form. I need to have a positive 1x here, which means I have to factor out a negative 4. That would give me an x. Be careful when you factor a negative 16. Factor out a negative 4 from a negative 16, I get a positive 4. Okay, now, the vertex is not so hard. Negative 4, negative 3. Negative 4, negative 3 is somewhere around here. Big $1,000,000 question. Which way does it open? Look at your non-squared term. That would be x. So that means it must open along the x, either left or right. Which way is it? The number in front is negative. So negative means it's going to open to the left. Okay, so now hopefully you can see your axis of symmetry is a horizontal line. And the equation of a horizontal line is a y equals. So y equals, it goes through the vertex, so what does y equal? Negative 3. All right, now, where's my focus? Well, let's figure something out first. 4p is negative 4. Divide by 4, and p is negative 1. Don't let the negative or the positive one concern you. I mean, It does help if you're not drawing a picture. If you're not drawing a picture, you know that from this point you need to move a -1. So you would either move to the left or down, depending on which way it opens up. If you didn't have a picture, but if you have a picture, you can kind of see you're going to have to go to the left one to get to the focus. So that might help you visually also. But either way, what are the coordinates of this point? Well, this one was -4, -3. If I move to the left one, to the left of one of a -4 is a -5. -5, -3. And finally, where's my directrix? Well, if I moved 1 to the left, I must have to move 1 to the right. And it's going to be a vertical line going through. So let's see, a vertical line is an x equals. I was at x being a -4. I moved over to the right one. I am now at -3. And there we go. That was a fun one. Parabolas can be difficult, but if you've got these 4 concepts and sometimes a picture, that can be very helpful to you in figuring out the pertinent information. All right.